Hello everybody and welcome back to day 6 of 30 minutes of problem solving a day. Let's go. And what we're going to be doing today is continuing where we left off on the 2018 February contest silver problem, teleportation, because a bunch of you guys asked for it. So honestly, I think I will go through what we had so far, and I think we were not very careful when we were thinking of the solution. So let's just fully beep out the solution before we actually start coding. I know we already started coding, but it's probably better to have a more full solution before we start. Okay, so we essentially have a number line, right? Okay, we have 0, and we found yesterday that the idea is whenever somebody is going from left to right, only a left to right teleporter will actually help them, right? Because if you go from here to there, right, from here to here, you essentially go to the teleporter, then you go right a little bit, and that helps you a bit, right? What we also found is that like if your teleporter ends up here, eventually it'll go past like twice this length, right? In which case it's better just to walk this length instead of going there and then walking back the same amount of length. It doesn't really matter. So that's what we found out last time, but I think one thing we forgot to do is because what happens if you go from here to here, right? Then if you go backward, it actually might help you because this distance is so short. So we also had to consider that. Let us see. So our basic like concept that we had last time was that we basically want to keep track of when each teleporter, like when each uh hay bale is getting improved, right? Like for example, if you have like -1 and 1, right? Any teleporter like 0 0 like 0. Actually, let's make this like 5 or something so it's a little bit easier, or 4 or something. So essentially, like any teleporter, like 1, 2, 3, or 4 will help, right? For sure, because essentially you're just cutting off that much from the teleportation, and as you go right, you're improving yourself more and more, right? But then eventually, once you put like the other side at 4, right? Then you go here, you jump to 4, and you're there, right? That's like the best you could do. Like if you move it more right, then you're actually decreasing how useful it is. And then eventually, like once you get to 8, right? Once you put the teleporter at 8, like you could either like go to 0, teleport to 8 and walk 4 back, or you can just walk 4 there. It doesn't really matter. So once you get to 8, like twice this number, you essentially, the teleporter stops being useful for that particular hay bale. So that is one thing we noticed. Now, first, before we get into like implementing that part, because this part's pretty easy to implement, right? Like from 0 to 4, it's actually going to be increasing, or sorry, decreasing, right? The amount of time it takes. And then from 4 to 8, it'll be increasing, and then from 8 and onward, it won't change at all. So we got to implement that somehow. And then the other thing we got to consider is what happens if you have 0, and then your starting point is here, and then your end point is like 5, right? Then where does the teleporter actually benefit you? So essentially, you have to walk back like 1 this way, and then the only time that'll be useful is that if you save 1 going this way, right? So essentially, you'd have to go to 2 in order to make this teleporter useful, right? Because going here than there is the same as going here than there. Okay, so that is good to know. Um, so essentially, we could think about it this way, right? If you have 0 and then the starting point and then the ending point, your the teleporter will be useful from here to here, like increasingly useful, right? Like 2 to here, and it'll be decreasingly useful from 5 to 10, right? Because when it gets to 10, you might as well just walk from 0 to 5, right? Or like from 1 to, actually no, wait, here it might be different. If you start with 1, right? Then your teleporter, you could either walk back 1 and then like come left 4. Yeah, okay, so from 9, from 5 to 9 is actually um, getting less useful. And then once you get past 9, then there's no reason why I would do it, right? Because essentially going 1, 0, and then 4 more is the same as going from, no, what? Oh, it's 1, okay, so it's 3, right? So if you go left 1 and then left 3, it's the same as us going from 1 to 5. Okay, so that makes sense. So from here to here is getting better, and from here to here it's getting worse, right? So essentially, this is the best point we could put the teleporter for this particular hay bale, but we have to balance all the hay bales at the same time. Then we also got the other hay bales, which are like -1, 0, what do we got? Like, let's say 4, right? So essentially, it's like from here to 4, it's always increasing, right? Like any point from here to here, it's always getting better and better. So once you get a 4, that's the best, and then it decreases until you get to 8, right? Once you get to 8, then it stops mattering at all. So I think the strategy here, what we want to do, is we probably want to do like something where we keep track of these points, and then essentially we know like we keep track of all 3 points for every single hay bale, right? And then once we get to like the starting point, then we start incrementing, right? Like this one contributes a +1, right? Like a +1 benefit. Then once we get it here, then it flips from a +1 benefit to a -1 benefit, right? And then from here, it flips to a -1 benefit to a 0 benefit. And we want to keep track of all the benefits of all the hay bales at the same time and just move from left to right and see where we reach the minimum. Okay, so what's the best way to do this? Let's see. So I guess we could do like, we could push to our, like a list, right? We could put like, let's say these were the 2 hay bales, right? So we would put the 3 points, which are, 0, like 0. So from here to here is +1, right? So 0, 1, right? It starts off at 0 over here, then 0, 1. Then from here, it flips from 1 to -1, so we can make it 0, -2, right? Because it goes 1, and then you subtract 2. So 4, -1, and we get 8, 8, 1, or 8, 4, -2, 8, 1. So then once you add all of these, you end up with 0 from here onward. Okay. Then we also put in 2, 1, then 5, -2, and 8, 8, 1. Okay. Because beyond 8, it doesn't matter. And then essentially just sort all these. So if we put it in sorted order, what do we get actually? So we get 0, 1, 2, 1, 4, -2, and 5, -2, 8, 1, and 8, 1. So essentially, from 0 to 1, we know that our benefit from the teleporter is actually going to be a +1, right? Because we get the +1 from here, so the benefit, overall benefit is going to be 2 times 1, right? Because each time we move 1 over, it's going to benefit us by 1. So by the time we get to here, our benefit is 2. Okay. Then from here to here, we know our benefit is +2, right? Because we got 1 and 1, so that sums to 2. And essentially, we get 2 times 2 is 4. So our total benefit is actually 6 now. Let's just draw out the number lines again. So we got 0, 1, 5, 8, right? And 2, okay. And then we got, and essentially we want to bring this from here to here, okay? And then we also have 0, -1, and this goes to 4, okay. 8, 4, okay. So now what do we want to do? So essentially, it's saying that if we put the teleporter at 4, our benefit is going to be 6. And let's just check that that's correct. So from here to here is 5 plus, so without the teleporters, your best is like 5 plus 4, which is 9. So with the teleporter from 0 to 4, essentially this guy only has to walk 1, right? And then this guy only has to walk 1 and 1. So then you get 3. So you can see our benefit is 9 minus 6 is 3. So this is working. Let's go. Okay. So that is good. And then from here to here, our benefit is actually 0, right? Because we subtract out the 2. So it's still 6 over here. And then from here to here, it's actually -2. So you get like -2 times 3, because 8 minus 5 is 3. So that becomes 0. Then our benefit from here to here is 1, but that's 0 still because you don't change it at all. Then from here on out, wait, shoot. What? Oh, this will be -1 from here to here actually. So from here to here is -1, but it's still 0, okay? And then from here to here is 0 onwards. Okay, so you just look through all these numbers and you see that 6 is actually our best benefit, so our answer would just be 9 minus 6. Okay, so let us just code that up. I think this is like the right way to do it instead of what I was doing before, but this should make sense. Let me just explain it again so that you guys, so that I'm not like completely trolling, but basically the way we do this, right, is we keep track of for each hay bale when it improves and when it doesn't improve, right? And for this guy, right, like from -1 to 4, as long as we keep our teleporter between here, it's always improving, right? Because we're cutting off this much, then we're cutting off that much, then we're cutting off that much, so that's good, right? But then, once we get to the other side of 4, it keeps it deproving, right? Because now you have to walk this extra distance, and you have to walk this extra distance, and so on and so forth, right? So between 0 and 4, you're improving by 1. That's why we have 0, 1. Then from 4 to 8, you're deproving by 1. So that's why we have the -2. Because like we'll just keep track of the total overall, how much is improving slash deproving, right? And then from here to here, it's 0. That's why we add in the 8, 1, so it cancels everything out. All right, let's do it. And we have to do it from right to left to right, and from right to left, just to check which one's better. So now that we actually have a good solution, now we can actually code it up. So I think it should be 2 different from our previous one, but essentially we also had to keep track of the ones where like b is greater than a and a is greater than 0. Okay. So let's see. So if a is less than or equal to 0, well, okay, let's just do b is greater than a first, right? In that case, if b is greater than a, then if d, or like we push back the endpoint, right, which is b, you push back 2 times b, and you also want to push back the max of 0 and twice of, or minimum of 0 and twice of a, right? Actually, no, what? No, max, yeah, okay. So, because if it's negative, right, we don't want to push negative, like, negative like 500, right, because that doesn't really matter. We would want to put 0 because that's where the teleporter starts. But if you start after the teleporter, then you want to put twice of that. Okay. So we would do RC, and also we want to make this only one thing, RC and LC, and we'll do parent int here. Type def, parent int, PII, okay, and then essentially what we would do is over here we would do pushback, like max, 2 times a comma 0, comma 1, okay. Then over here we would put, is there a problem here? Wait, what? Oh, okay, okay. PII. There you go. And then we would push back b, comma -1, right? That's the endpoint, or -2. And then we would push back 2 times b, and then comma 1. All right. Wait, actually, wait. So for this guy, how do we get this with 8, right? We basically found that this was 4, right? This is 4, and we got 4, and then we subtracted out whatever this is, right? So we did a minus, or b minus 2a, and then added it to b. B minus 2a added to b, so I guess it's just from here to there. Huh. Well, I guess, so that will end up being 2 times b minus a, right? Because b plus b minus 2a. But when, okay, so could a be twice, so if 2a is to the right of, okay, so what happens if this was like 3 comma 5, right? You want to go from 3 to 5? Then it never makes sense to go to the teleporter, right? Because 2 times a is over here, so the teleporter only starts being useful here, but then it just gets worse from there. So if the teleporter is here, it doesn't make sense to walk back 3 and then just to get like 2 forward, right? So if like 2a is there, then we have to ignore this whole thing. So if b is less than 2 times a, we continue. All right. And then we'll have an else here. We don't need an if there. So what do we do? 2 times a is 0, and then 2 times b minus 2 times a. So you do b plus b minus 2a, and then that's 1, alright. And RC. Okay, now we do the same thing for the other side. Let's go. Bro, okay, so we could just copy and paste this whole thing. We will flip it around, so a is less than, wait, what? So it is still 2a, but okay, so it has to be greater than 2a. Because, yeah, okay. Then, in that case, we would, or what about greater than or equal to? Because then it just doesn't matter where you put it. It'll just always be worse to use the teleporter, so we'll do less than or equal here. Okay, and then we make this all else's. Alright. Yeah, that should be good. Okay. I'm pretty sure that should be good. Let me just, oh, so here it should be min over here. Okay. Because these are all negative. Or why don't we like made them positive instead? Like, we just flip it around. Like a is equal to negative b, and then, because then if we flip it around, then we don't have to like special case it or anything. Yeah, so why don't we just do like, we could just do a is equal to negative a and b is equal to negative b, and we could literally just do the exact same thing over here. LC, LC, LC. Okay. And basically the two cases are either the teleporter goes from 0 to a positive number, and then this case is if the teleporter goes from 0 to a negative number, so that is good. And now we just sort it, and that'll sort it by the first thing first, so that's good. Well yeah, we should probably sort both. I'll just do RC first just so we get it, and we also have our benefit thing. So essentially what we're going to do is we're just going to loop through all of them, and our prep starts at 0. So for pair int in, pair int or PII in, or in what was it, RC, right? Then essentially we would do benefit, or well, okay, so we want to multiply the benefit first, right? So we do like benefit plus equals, and then decrement starts at 0 too. We'll just say we'll call it increment because that's what we did in our example. So increment starts at 0, and then benefit plus equals increment times p dot first minus prep. Okay. Then we do increment plus equals p dot second, right? And then what do we do? Prev. Let's see. Wait, what happens if it's like both of them are on the left side? Then we don't want to consider it, right? Like if we're making our teleporter go right, it doesn't make sense for two things on the left side, even if they're going this way, to use the teleporter, right? So we should also keep track of that. If b b is less than equal to 0 and a is less than equal to 0, then we also continue. All right. So our increment gets plus by that, and then we do prev is equal to p dot first. And essentially we want to keep track of the max benefit we get, so int max benefit equals 0, and then max benefit equals max of benefit, or max of max benefit, comma benefit. Okay. And then we literally just repeat this for LC, and we should be good. And at the very end, we see out max benefit. Oh no, we do our, well, we first had a, okay, so we first found out our total distance, right, our initial total distance, and then we subtract max benefit from that, but let's just make sure we get the right benefit. How much benefit do we get here? So 2 plus 13 is 15 plus 9. That's a lot of benefit. 24, so you get 14 benefit for this one. That's pretty insane. And that should be PII. Oh, whoops. Let us add a file. Teleport.in. And we'll put this in. Go see. Moment of truth, boys. Is it not even going to run? This is so sad. Oh, did I put C in? Oh, nice. Okay, F in over here. Let us see if this works. Hey, it worked. Dang. Alright. Well, that's a cool problem. What the heck? I like that. Okay, but anyway, let's just make sure our thing works. We have our int dist is equal to 0, and then we just do dist plus equals abs A minus B. Okay, and we'll probably include math.h. Alright, nice. Whoops. Dist minus that. Dang, why is this thing so long to compile? Is my internet bad? Okay, very good. So that is working. Let us just try it out, and we should see if we actually got it right. Hopefully we did. I feel like I thought through that pretty well. Okay. Okay, I might have to edit this one slightly. Bruh. I said my password out loud. Small brain, dude. So, we got our teleport. We should probably unzip it first. Extract all. Okay. Teleport main. Plus work. I beg. Come on. Do it. I dare you. I dare you to work. Let's go. Oh no. What? Cannot deduce templates for grader from what? Let's see. Maybe I have to do. Okay, let me just try, like, specifically telling it to do that. That. Okay, let's just try that. I don't know whether I could use grader. If it worst comes to worst, we'll just like. Oh, I don't want to do that actually. I don't want to actually do that. Okay, just do that because we already negated everything. Okay. Let us try that. Dang, that compiler error actually saved us from a very untimely death. Maybe. We'll see. Maybe we'll still. Oh, we still died. Holy moly. What? Oh god. What? Okay, let me think. So, we got 2, comma A and 0, right? And then we have, if it's less than 2 times A, continue. Less than 0 and less than 0, then continue. Okay, let's just try it with our test case that we made. Bruh. Bruh. This is so sad, my Wi-Fi is dying. Hold up. Wait, we could, okay. Maybe this is why you use a local IDE. Maybe I should do that. At least for now. Okay, so download teleport 2. I really don't have anything. Okay, well, this worked. So we got 2 and we got 1 comma 1 5, right? And what was our other one? Negative 1 4. So this should give us an answer of 3. And that works. Okay. Same position Y is used during transport of every pile. Okay. Let us try negating this just to see if that works, because maybe our left side is not right. I don't know. I'm pretty sure we did the same logic for left and right though, so this should also give us 3. Okay, so that is not the problem. Let us figure it out. No, don't want to look at the binary. Okay, hold up. So we essentially get our distance. That should not be too problematic, right? Then you sort it. 2 times A. What? So then you get your endpoint, which goes, yeah, okay. Increment plus equals p dot second, okay. And then prev is equal to p dot first. Oh, wait. No. It's for sure positive, right? Okay, I guess we just want if b is less than equal to 0. But I mean that shouldn't change anything because a is for sure. Wait, what? No. Hold up. So if the endpoint, okay, so b is greater than a, so this should work. Okay. Then if you push back that, So yeah, this is for sure in the right order. Okay, hold up. Let's just double check that we were doing this part right. So it goes from 2 to 5, and then you also want, so you got like 5 minus 2 times 1, and then plus b, which is 5. So that gives us the right endpoint. Huh. What in the world? Okay, let's see. Let's just try using long because I don't think that's a problem, but we might as well try it. What else could be the problem? I'm sure there's some negative thing that might be throwing it off, but I'm pretty sure it'll never be negative because, well, I mean, A might be negative. No, it can't be negative, so that's also not a problem. Huh, that'd be weird. Let's think. How much time have we spent? Oh, it's almost 30 minutes already? Okay, well, don't worry. We'll finish this today. Okay, I will stay a little bit longer if necessary, but what do we got? Okay, we just need to think of a random test case that might not work. Cause I don't feel like I'm gonna get it just by staring at this. Really? I'm pretty sure that's how you're supposed to do it, though. Okay, let's just see. Alright, seems legit. Yeah, that makes sense. And that should be right, okay. Oh, bruh, I didn't set it to 0 everything. Okay, so all this stuff has to get set to 0 once we do this. Alright, that makes so much more sense, dude, holy moly. Bruh. Okay. Well, I mean, I should have done the long anyways. Probably should do distances long as well. Okay. And now let's try that. Dude, I'm actually happy that I might have actually found what was wrong. That would have been sad if I didn't. Okay. So, we got that. We do that. We do that. Teleport 3. Main. Moment of truth. Come on, please. Do it for me. Come on. I beg. Please? No. What? What? Hold up. Hold up just 1 second, dude. Am I really trolling that hard? I feel like, bruh. It isn't necessarily an integer, pretty sure. um, let's see. Huh. What? Okay, let's see. What's a very fancy? Okay, let's just do like 5, and then we'll just put some random stuff. 6, 5, or 7, 9, or I don't know, 5, 8, 10, or 0, 8. I don't know. 4, 2, 4. I don't know. 4, 0, -8. That's probably more than 6. Oh, that's 6. Okay. So what does this give us? And we gotta solve it ourselves. So this gives us 19, alright. And essentially we got, let us draw this out, -1, or okay, so this is 0, -1, -5, 1, -4, 5 and 8, 0 and 8, 2 and 4, and 0 and -8. Okay. So -1, -5, -4, -8, 1, 2, 4, 5, 8. Okay. So this 1 is going to -4. Let's draw this stuff. 0 to -8, 0 to 8, and 2 to 4, and 5 to 8. Okay. So it seems to me that the best thing to do would be actually to do 0 to 5, just eyeballing it, right? Because then this guy would be 2, right? Then this guy would actually be 1, right? Because you go -1 there. So you get 2 plus 1, and then 0 to 8 gets from 0 to 5, right? So that would be only 3 actually, plus 3. And then none of these guys would actually benefit that are going this way. So that would be plus 8 plus 2 plus 3. So that gives us 13 plus 6 is 19. What? What? Am I misreading the question or something? Let's see. Huh, I'm actually so confused. I'm pretty sure that's... What? Am I... What? I'm so confused. Single number of the minimum sum of di's. I feel like I'm probably making some stupid mistake, but max benefit, alright. Prep is 0, that's right, starts at 0. Increment starts at 0. So yeah, I want to find the max, right? Starts at 1, -2, 1, alright. Oh, bro. Oh my god. Oh my. Dude, I'm actually so... God dang. Should be like this, -0. Oh god. That is so sad, dude. How did I not see that? Bruh. Because this actually should not be 2a. There, okay. This should actually work. Let's try that. Alright, let's do it. This better work, okay? Otherwise I'm gonna be very angry. Alright, hey, there we go. Oh my, dude, that was the stupidest mistake ever, dude. I literally knew, I was like telling myself to do this at the time, but I didn't do it. Okay, whatever. We got it, okay? We finally got it. Let's go. Anyways, that is what we got for today. That was a little bit over 30 minutes, but that was a fun problem, actually. I don't know why I was so bad at implementing it, but it's okay, okay? Took us like 50 minutes to solve this problem, which is kind of not ideal, but it's okay. I'm kind of rusty, I'll admit. But anyways, thank you guys for watching. As always, if you enjoyed the video, leave a like and subscribe for more. If you guys have any other suggestions, leave them in the comments. I would be happy to do anything you guys want. But I hope you guys enjoyed. Other than that, thank you guys for watching again, and see you guys next time. Let me turn off the video. Dude, I actually need to figure out how to turn off this without being awkward. Okay, get out of here. Bye-bye.